Okay, just now we were interrupted by telephone. So we're gonna continue on this just to finish this up. Okay, what's the question? What's the question you just made?
Isn't there supposed to be time on the power over here?
What's the power?
Like one.
No. I mean, is it money or time? Y or T?
T.
T, right?
Yeah.
Yeah. Let's look at this. Actually, this is 6% is an average number.
Mm-hmm.
You actually make money in every little bit of time, right? The money you make changes. Yeah. In other words, what you're really doing is dy dx. Let's just call it d money dt, right? Right.
Mm-hmm.
Is a certain constant, right? Compared to the amount of money you have.
Yeah.
Right. You know the solution for this? We can just solve it. Do you know? Let's solve it. C is a plus number, obviously, right?
Yeah.
Okay. Now, dm dt equals to cm, right? How do you solve this? How do you solve this?
What do you want me to solve? What?
You want to take out the derivative.
Oh.
And so what's m to t? You want to have this m t come out. You want to understand how when you put in the t, what's m? At any given time, what's the money? Right? You don't want to, how you don't really care about the rate of change or whatever. You just want to know what about 3 years down the road or 30 years down the road, how much money I get.
So don't worry about the constant.
Yeah, right, exactly.
Then it'll be m squared divided by 2 times the constant.
What do you mean by that? Ready? Try it. Do the dm dt. Oh, by the way, you want the t. You want to put in the time to get the money, right? By the way, this is not dm. This is dt. We're talking about the t. We're not talking about m.
Okay, I'm good.
You're good or you're bad?
Bad.
Okay, let's put it this way. M kind of bother you, right? We just call it y. Or t probably bother you. We just call it x, right? Does that make sense? Does that help you?
No, I saw it like that the first time. I just don't know how I might.
It's okay. Do this. That help you. If it's not y, if it's x.
Yeah, helps a bit.
So what's the solution for this?
What's y?
Yeah. Y equals to fx, right? What's fx?
Constant x squared divided by 2.
Right. Yeah. Right. In this case, y equals to we just say some constant x squared, right?
Yeah.
So when you do dy dx, dy dx equals to 2c x in this case, right? So this c actually is half of this c, so to speak. Yeah. Right.
Yeah. I just said that. Okay.
But we're not looking at this, right? We're looking at this. So what's the solution for this? Let's look. Let me do it again. Okay, just look.
Okay, I'm looking.
Okay, dm dt, d money dt equals to certain number times money, right?
Yeah.
Money is a function, t is a variable.
Yeah.
Okay, I'm gonna move the money in the same place, right? Same side, right? Okay, so this side is just t, this side is just m.
Okay.
So I'm gonna take an integral of it, right? I'm gonna take an integral of it. Forget about the constant.
Okay.
So what's this? 1 over m dm. What's 1 over x dx? Right. Log m, right? What's this?
That's wait.
C is a constant.
And just t.
Yeah, ct, right? Right?
Yeah.
So what is m?
Is like e to power ct whatever.
Yeah. That's what you call. You know this answer, right? You know this exponential, right?
Yeah.
You wake up.
I know it's exponential.
Yeah, this is how you get. And we normally do 6%. For instance, when we just about 6%, right? It's 1.06 to the power n. This n is number of years, right?
Yeah.
All we're doing, you're changing the. This is what we're talking about, is changing the bases, the base, right? When you're talking about changing the base, all you're doing change is this constant. You see that? So we're not dealing with this constant right now. Do you get what I'm saying?
Yeah.
Yeah. You want to change this to 1.06, all you're doing changing c, then you change the base. We just did that before. If you have a problem, you look before. Okay, now one more thing I want to talk about to essentially to straighten up the let's see what we have here. Yeah, we're obviously this you didn't quite get. We're gonna come back to this more. Next time we'll review this. We'll let you take a break and all. We talk about when we do the geometry problems.
Yeah.
You need to draw extra lines, right?
Yeah.
There's a name for that line. It's called auxiliary line. Okay, I just want you to know these proper names. I looked it up. Okay. And when you have a problem, a geometry problem, you don't know how to solve it, start to draw some lines. Definitely try to draw some circles. Okay. But you want more than 3 points on the circle. If there's only 3 points on the circle, you're not going to get much, because all you have when you have a triangle inside the circle like that, you're not going to get much. You know, all these 3 angles added together is half of the whole thing, which is 180. You know it, right? You don't need a circle to help you with that, right? However, if you have another point on the line, this is the time you want to draw the circle. All the similar triangles, all kind of business going on, equal angles everywhere. Yeah?
Yeah.
That makes sense? Okay. We'll get back to that. We'll get back to this business next time, just to sort of go over it again to get some sense into you. But anyway, that's it. That's it for today. See you next time.